In this video, I'm going to show you how to convert between standard form and vertex form of a quadratic. And this process is called completing the square. But before we get to that, I want to talk about perfect square trinomials because it's part of the step to completing the square. Now, a perfect square trinomial is a quadratic, ax squared plus bx plus c, where if you take your b value and divide it in half and then square it, it'd be equal to what you get when you multiply your a and c terms. And it's useful because if you were to, you can actually take this and write a perfect square trinomial as x plus the b over 2 term squared. So let me show you some examples. Let's take x squared plus 8x plus 16. If I were to take the b value, which is 8, and divide that by 2, I get 4. And 4 squared is 16, which is equal to this 1 times 16. So I can rewrite this expression as x, and this is a positive 4, so plus 4 squared. Another example. If I have b squared minus 10b plus 25. If I take this negative 10 and divide that in half, I get negative 5. And negative 5 squared is 25, which again is what I get if I were to take 1 times 25. So it's a perfect square trinomial, and I can write it as b minus 5, because this number here is what I put there, squared. Now, the reason I was showing you this is because, again, it is a step to convert between standard form. Remember, standard form is the one where it's written, a quadratic is written as ax squared plus bx plus c. And then vertex form, which is written as a times x minus h squared plus k. Completing the square is a process that goes from this form to this form, and perfect square trinomials play a part in that. Alright. So I'm going to give you an example. X squared minus 8x plus 18. Alright. To complete the square, the first thing you're going to do is group together your x squared and x terms. And then you look at your x squared term to see if there is a number that is not positive 1 in front of it. In this case, there's not. So we can go on to the next step, which is, I'm going to rewrite this with the x squared minus 8x in parentheses. Then I'm going to put a plus symbol and leave a little bit of space. Because what we're going to do is we're going to change this into a perfect square trinomial by adding b divided by 2 squared, because again, perfect square trinomial, that has to be true. But I can't add a number without changing the value of my equation. So what I'm going to have to do is outside, I'm going to have to subtract that number back. So what I'm going to do is I'm going to take the b value divided by 2, which gives me negative 4, and I'm just going to square that value. Negative 4 squared gives me 16. And because there's no number, the number in front of x squared was just a 1, I can just put this same 16, not just here, but also over here. And now I can So this is a perfect square trinomial. So this means I can write this as x and then take this number, what's in the parentheses here stays in the parentheses here. So x minus 4 squared, and then 18 minus 16 is positive 2. Now doing this is pretty useful because you can get a lot of information by looking at it in vertex form. I can tell the vertex is positive 4, positive 2. I can tell that the axis of symmetry is x equals positive 4. I can look at this and tell you that the graph shifted right 4 from your parent function and up 2 from the parent function. So having it in this form allows me to see a lot of different information. Let's look at another example. But this time, let's look at one where your a value is not positive 1. Let's take 2x squared minus 12x plus 13. Process is the same. You're going to group your x squared and your x. But this time, what we have to do is we have to factor out the 2. So I want to pull the 2 out front. But when I do that, that means I have to get rid of the 2 here and here. So when I divide that, I'm going to get x squared minus 6x. And if you were to distribute it back, I would get the original 2 terms. So I'm not changing the value, just how it's written. Then we do our plus, leave a little bit of space, bring down the plus 13, and go ahead and put a minus sign. Now, the next thing I'm going to do is complete the square, which, remember, that's where we take the middle term, the b, divided by 2, which gives me negative 3, square that, and I'll get 9. So we have a 9 goes right here. But you have to be careful. I'm not going to put a 9 out here. The reason I'm not going to put a 9 is because this 2 out front means that if I were to distribute that back in, I would not have a 9. I had 2 times 9, which is 18. So now that I've added the numbers here and here, I'm going to go ahead and simplify. The 2 out front stays in front. This is your a term, like in the vertex form that I wrote earlier. Perfect square trinomial here can be written as x minus 3 squared, and then 13 minus 18 gives me negative 5. So again, by having it in this form, there's a lot of information I can get. I have a vertex at 3, negative 5, axis of symmetry at x equals 3. I can tell you that there is a vertical stretch by a factor of 2. It moved right 3 and down 5 from the parent function. These are all things I can tell just by looking at it in this form. Now let me show you what would happen if we had a negative out front. And I'll actually combine a couple of steps here. Let's say I have negative x squared plus 3x minus 2, because there's going to be a couple of things going on here. So start same way as the previous one by grouping your x squared and your x terms. I have to factor out the negative, so I'm going to end up dividing both of these by a negative 1. When I rewrite this, I'm going to end up with f of x equals negative positive x squared minus 3x plus a little bit of space minus 2 and minus. So the next thing is like we did before. I'm going to take the b term and divide it by 2, but 3 halves does not divide evenly, so negative 3 halves is what I'm going to square, which gives me positive 9 fourths. 3 squared is 9, 2 squared is 4. Now I'm not going to put a positive 9/4 out here though, because I have this negative here. So I have to multiply this negative times 9/4 to put negative 9/4 out here. So we're subtracting a negative, which really means we're adding. So when I rewrite this, I'm going to have negative x minus 3/2, remember this number is what goes in the parentheses, squared. And then over here I have negative 2 plus 9/4. Well, without a calculator you can still do this. We have negative 2, that's negative 8/4. Negative 8/4 plus 9/4 is 1/4. So again, you can look at all this and get information. I can tell that the vertex is at positive 3/2, positive 1/4. I can tell that the axis of symmetry is x equals 3/2. I can tell that it's been reflected. It moved right 3/2, up 1/4. So one more example I'm going to do. Just to show you what you would have to do if we had a fraction already in the function. So if we had a fraction already in the function, let's take okay, 1/2 x squared plus 4x plus 7. Okay. Process is the same. Group your first two, x squared and x. You're going to have to factor out that half. So when we rewrite this, half is going to go in front, and then to factor it out you have to divide these by 1/2. So this half divided by half, number divided by itself, is just 1x squared. 4 divided by half is 8, then plus a little bit of space, plus 7, and then minus. Divide this by 2 and we get 4. Square it and you will get 16. But I'm not going to put a 16 out here because I have this half up front. I have to multiply these two terms, which gives me a positive 8 out here. So when I rewrite it, I get 1/2 x plus 4, because positive 4 here, squared, and 7 minus 8 gives me -1. So again, I can tell all kinds of information by looking at this function in vertex form. I can tell you the vertex is -4, -1. I can tell you the axis of symmetry is x equals -4. I can tell you what kind of transformations we're done. We have a vertical shrink by 1/2. We have a graph that moved left 4 and down 1. Now let's say you do this, but you're not 100% sure you got the correct equation. You can use your calculator to test it out. So let's say you weren't sure if you did this last one correctly. What you can do is type your original equation, 1/2 x squared plus 4x plus 7, into y1, and then type your answer into y2. So 1/2 times x plus 4 squared minus 1. Then if you do second graph and look at the table, you can see that our points are all the same. This means that we do have the same equation, and you can probably graph it and see that there's only one line. So you can use your calculator to double check to see if you did it correctly. Alright, and that's it for today. Have a good one.